Hello, and welcome to the Boost Hydraulic Force webinar. The topic for today's conversation is all about intensifying hydraulic pressure in turn to generate more force easily and cost effectively. I'm excited to share this technology with you today because for the first time, there is a plug-and-play solution that can boost hydraulic force in many applications without the need for purchasing a more expensive system. In the past, the primary option for increasing hydraulic force was to buy larger hydraulic cylinders and pumps, or a single-shot intensifier. But what happens if you don't have space for larger components? What if you want to avoid redesigning or rebuilding your whole system? What happens if you don't have the budget or can't afford system downtime? Thanks to extensive engineering and product development, these factors are no longer a concern. I'd like to introduce you to miniBOOSTER. miniBOOSTER is a point-of-use solution that can be mounted to a low-pressure hydraulic system to substantially boost pressure. miniBOOSTER automatically intensifies system pressure and is available in a vast range of configurations to integrate seamlessly into a variety of different applications. As next-generation hydraulic equipment is being designed by engineers today, we want to take this opportunity to raise awareness of miniBOOSTER and let you know that this capability is available to you now. In today's webinar, we have experts with extensive experience in the hydraulic market who are going to walk you through how miniBOOSTER works and how it can be implemented into your application. As you can see in today's agenda, we're going to start with a technical overview on just how miniBOOSTER works. Then we are going to transition to a live demo and show you the performance of miniBOOSTER in action. Next, we'll walk you through the different hydraulic applications where miniBOOSTER is a good fit for increasing hydraulic force, followed by specific case studies and customer success stories. Then we'll finish up with some open discussion and questions. We ask that all questions are held until the end of the presentation. With that, Bill, would you mind starting us off with a quick overview of the product?
Hi, I'm Bill Niblock with ASP. miniBOOSTER Hydraulics has a very big family of hydraulic intensifiers. And while the size and shape of the intensifiers are quite varied, their function remains the same. The miniBOOSTER intensifier is a point-of-use solution to the need for increased force by way of supplying intensified pressure. Taking a look at just a few of the members of the miniBOOSTER family, you can see that the size ranges from small to large. Some, like the HC2W, are in stainless steel and capable of intensifying clean water. In some cases, the intensifiers have threaded connections, such as the HC1 and HC2 family. The HC3 family offers alternate mounting opportunities, such as an NG6 manifold or face mount design. For larger intensified flows, the back-to-back variants from the HC2D to the HC6D to the HC6D2W dual media intensifier have solved application challenges from railroad repairs to subsea seal testing for the oil production industry. Finally, miniBOOSTER has continued to extend the ability of the intensifier to solve the need for intensified pressure in a multifunction format that increases system efficiency while at the same time extending the service life of the intensifier. In the case of the HC25, integral to the intensifier, or like the MHC3 series in a manifolded solution. Incorporating sequence or counterbalance valves to reduce cycle times by controlling the operation of the intensifier to only when needed, or pressure reducing or pressure relief controls to keep the intensifier in a safe operating range and extending service life. miniBOOSTER is the global leader in the design and manufacture of oscillating hydraulic intensifiers. On top of that, they are leading the way with complete plug-and-play intensified pressure systems for a multitude of industries. Let ASP and miniBOOSTER help you with your next project that needs a cost-effective solution to the need for more force. Now, Let's take a look at the miniBOOSTER in action. Hi again. Here's a sample of a hydraulic system that includes a miniBOOSTER hydraulic intensifier. In this case, it's an HC2 4.0 B-1. HC2 is the booster family. 4.0 is the intensification ratio. If the system pressure is 500 psi, as in this case, the intensified pressure will be 4 times that, or 2000 psi. The hydraulic schematic shows how the balance of the components are interconnected. The beauty of this system is we can demonstrate how an intensifier functions under a number of conditions. We will start the system with the control valve in the neutral position, and energizing the low pressure pump will permit circulation of the hydraulic fluid through the system without engaging the hydraulic cylinder. To extend the hydraulic cylinder, we'll place the control valve in the extend position. You can hear the miniBOOSTER oscillating as it attempted to intensify the hydraulic cylinder pressure. It isn't until the hydraulic cylinder reached full extension that the intensifier stalled, having reached the 2000 psi set point. The intensified pressure will be maintained until the control valve is reversed. One of the invaluable features of the miniBOOSTER intensifier is that it is a self-compensating device. If there happens to be leakage on the high pressure side, we can demonstrate by opening the dump valve slightly. The miniBOOSTER re-engages to try to maintain the intensified pressure set point. In some applications, it's important to have a stable pressure while intensifying, perhaps to prevent false pressure transducer signals. Since the miniBOOSTER is an oscillating device with pressure fluctuations as it cycles like the pistons in a car, adding an accumulator to the system can be an effective solution to limiting pressure fluctuations. We can demonstrate by opening the valve to engage the accumulator. Please note that the intensified pressure is stable now. The intensifier is continuing to oscillate to compensate for the lost pressure. However, instead of pressure fluctuations, the accumulator keeps the intensified pressure stable. Finally, most miniBOOSTER intensifiers are available with an internal pilot open check valve or a pilot to close pressure relief valve to release the intensified pressure via the intensifier. If the pilot to open check valve, the check valve is engaged by way of swapping the P and T lines to the in and R ports of the intensifier respectively by way of the control valve. Wisely, the pilot ratio on the check valve is higher than the intensification ratio. However, if there is a slight loss of system pressure, the cylinder cannot be retracted. That would be the advantage of the PRV. Well, that's a brief introduction to the miniBOOSTER in action. miniBOOSTER is a cost-effective solution to the need for intensified pressure, particularly when only one operation requires higher pressure, or there is a weight, envelope, or volume limitation. We'd love to hear from you with questions about miniBOOSTER and how a miniBOOSTER intensifier can help your process be faster, more reliable, and cost-effective. Thank you, and now let me pass the presentation over to Mike.
Good afternoon. My name is Mike Erickson. I'm the sales support specialist for Zynga Filtration Group. as well as the product specialist for the miniBOOSTER intensifier product line. I sit in Reedsburg, Wisconsin. I have a degree in fluid power technology, and I've been in the business about 30 years or so. So I kind of got an idea of what's going on. We're going to talk a little bit about the miniBOOSTER and where we would use them, and just kind of give you an idea of what you'd be looking for in a customer and in an application. Okay, why would we use hydraulic intensifier instead of other methods, just the conventional methods of just open loop hydraulics? Would you do it to increase your machine work capabilities or your system capabilities, improve them because it looks good? They're kind of nice looking little pieces of equipment, or economics. In actuality, the answer is all of these are good reasons to use an intensifier. We will increase the capabilities of the machine by increasing the pressure. You'll improve your system by increasing its capabilities and doing the same or more work with less pressure. It also helps to look at it. It also looks good when your system can do the same work at lower cost than your competitors can. And when you add everything up, that's just good economics. When does using an intensifier in a circuit make sense? You can't just, say, okay, we're going to use one and, hope that it's going to hope for the best. You usually want to have some thought behind it. And one good rule of thumb is, considering when you're using an intensifier, the actual need for higher pressure within a circuit to create the force or the torque should be like a short time frame within the total cycle, or something where you could lock that pressure in. Think about it, the hydraulic system only generates the pressure that's needed to create or to do the job at hand. If the job required high pressure for just a short duration, then why would you size the system with either high pressure or higher flows for the complete cycle? It's a waste of money. So if you only need something for a couple seconds and your whole cycle is an hour, then you're saving your customer and yourself a lot of time and money. Here we see a press that's about ready to destroy this nut. And you can see that it's not in contact with the nut at all. And now as it moves down, it starts to build pressure on it. This is where a miniBOOSTER would actually help out your circuit. You don't have to have this big tonnage or big pressure pushing that the full time. It can just be right after you make contact and you do the job. How can an intensifier do this? Well, the answer is physics. It comes right down to the simple equations for how you would generate force or torque. Force being F equals the annulus area times the pressure, or torque is the displacement times pressure divided by 2 pi. If you look at it, your pressure is a common factor within these equations. So that's why if you change that, you can change the output of the actuator. There are other ways of doing it. You could change your annulus area. You could change your displacement of your motor. But then you're going to be changing a lot of other things also. As with everything, nothing is free in hydraulics. When we size up a system to increase pressure or flow, it's easily very costly. Here's the shopping list that you'd probably be looking at if you wanted to increase either the pressure or the flow. On the pump, if you're going to increase the pressure, you have to make sure that your pump can handle the pressure that you're going to. as well as if you increase the flow. Your pump is going to have to be able to flow enough. Hoses and pipes, they've got to handle either larger flows or more pressure, sometimes both. Your valves, same thing. They have to handle the pressure. They have to handle more flow. And this is going to be integral in the circuit. Your filters, again, you're going to have higher flows. If you got a pressure filter, you might have higher pressures on that. Your prime mover, in other words, your electric motor, your gas engine, your turbine, whatever you've got. If you have to increase your horsepower to get more flow or to get more pressure, you're going to have to make sure that that can handle it. This becomes important when you're looking at gas engines or diesel engines, because I believe it's over 30 horsepower. It starts to get very expensive with these new tier engines, these tier 4s and that. Your fittings have got to handle higher horsepower or handle higher pressures or handle higher flows. So you have to look at that also. And then getting down to the actuators on your pressure, you got to make sure that your cylinders or your motors can handle the higher pressure if that's the route you go. Or if you're going to increase the flow, you're going to have to upsize both of them so that you can get the torque out of them or the force that you need. Now here's a shopping list if you wanted to use an intensifier. And I'm just taking this as if you've already got the circuit or the system already designed. You can use the existing pump. Hoses and pipes, for the most part, them are going to be the same. Your valving will be the same. Your filters will be the same because you're not going to be flowing any more and you're not going to be raising the pressure where the filter is going to see it. Your prime mover is going to be the same because you're going to have the same horsepower requirement. Your fittings, again, you're going to be able to use whatever the pump and valves can handle. So you're going to be fine with that. The only thing you have to look at is the actuators. Sometimes them will handle the higher pressures, sometimes not. And that would be for both the pressure and the flow. And then you have to have naturally the intensifier. And if there's a fitting or something like that between the actuator and the intensifier, that's all you're looking at changing. Applications where you could benefit from using an intensifier. Naturally, presses. This press you see here is a big die casting press. Where you'd use that is when the die is closing, you're using very little horsepower or pressure. When it gets all the way, the dies are together, it's all the way down, and it has to hold the pressure within while it takes the shot of plastic or aluminum or whatever it's taking. It's got to generate high pressures. That's when you would increase the pressure using an intensifier. When you're done, you release the pressure, it backs off, very low pressure then. Clamping circuits, you'd see them in machine tools, that kind of stuff, anything to hold materials. Winch circuits, see them a lot in, let's just say a wrecker or on a ship or something like that, even a mooring control. Rescue equipment. What I think of rescue equipment, I think of like the jaws of life. You've got a small portable tool, and it's just at times you need a lot of pressure. This would work great for that. Hydraulic power tools. A lot of them are used on the railroads or in forestry and that kind of stuff. Hydraulic grapples for grabbing things. And then there's hydraulic shears. Again, that's something that you don't need the pressure all the time. It's just every once in a while you get something really tough, you've got the horsepower to do it. My final thoughts on it. Another avenue to think about when you're working with intensifiers. Look at applications that, don't necessarily need the 2,000 or 3,000 or above and above. You can actually look at them and say, okay, I need 2,000. I need 3,000 psi. I don't want to have a great big power unit. I don't want to have a lot of horsepower out there. You go with a little power unit that does 1,000 psi, and you can use a ratio of 1 to 2, or 1 to 3. Get your pressure up, do your trick. It's done. It saves you a lot of time, weight, money, and real estate, especially if you got a small power unit, maybe even something that's mobile, or something you want to carry around. You keep your power unit very small, and so a couple guys can pick it up and carry it. Tell you, a few pounds off of that, and everybody's going to really love you. So I just want to thank you very much for listening, and have a good day.
Thanks, Mike. Those are definitely some solid reasons why somebody would want to implement miniBOOSTER. I think you gave some really good examples of how it can save time, money, and space, among other things. Let's take a deep dive into some specific real application we've worked on. Our next speaker is Stan Asklund, who has a lot of experience supporting customers with miniBOOSTER. Stan, can you walk us through some of your most recent projects?
A couple of applications that I've worked on over the years and recently here with some customers that where miniBOOSTER worked out well. Recently, I had a customer that wanted to test components on a hydraulic test stand. He wanted to be able to go up to 10,000 psi. So we talked about a couple of options. He was considering looking at a small high pressure power unit, something that would be independent, similar to a competitive unit like Enerpac, and where he would have to, in that case, install a wiring system or to get it to operate. He would have to have some control valves to operate it. The plumbing, he'd have to have high pressure plumbing to go to his component to perform the tests. So we got talking about it, and I suggested that he consider a miniBOOSTER. And some of the pros and cons, I've listed a few of the cons there, being he'd have to buy that high pressure power unit, whereas he could tap into his hydraulic system on his test stand and use that to drive the miniBOOSTER. He would have to, as I mentioned, plumb high pressure plumbing from the power unit to this test device, whereas with the miniBOOSTER you can have a point of use test. So you can put it right at the cylinder and have very few high pressure 10,000 psi connections. He wouldn't have any additional wiring. He could operate the miniBOOSTER with just a manual 4-way directional valve to perform the test functions. And then the miniBOOSTER is a very small package that we were looking at. It's relatively small. It's about the size of a can of pop is kind of what I refer to it. Whereas for him to purchase this little power unit, it's a larger, heavier, more storage space. It's something that he would just takes up a little more space when he's not using it. And then the final, probably largest thing that he was looking at was the cost. I don't know if you've costed out these high pressure power units are relatively expensive. A few $1,000s isn't uncommon, whereas a miniBOOSTER in this case came in much less expensive than what he was looking at going the other way. So that was a good application for a miniBOOSTER, and it's worked out well for him in that particular application. Another application that I recently worked on a customer with was on a filter press. This is in the past, this customer had used a air over hydraulic power pump to operate it, but filter presses have a fairly good sized cylinder, at least his did. And so with an air over hydraulic unit, it took several minutes to extend and retract the cylinder to open up the filter press and clean it out. And with the miniBOOSTER, he had could achieve a much higher flow rate with that. They've also, and another, the customer also had another filter press, and they had a power unit with a pressure compensated piston pump. So the piston pump would operate the system fine, but when when the filter press is under operation, it's holding a roughly, I don't know, 2,500 to 3,000 psi. It depends on the design and what you're doing, but and when you have a pressure compensated pump holding that pressure all day long, there's inefficiencies, leakages around the piston pump, and over time could operate and get hot. So you've got to install coolers to keep the system cool, and they were actually using a water cooler. So in working with the customer and talking about it a little bit, he decided to look at the miniBOOSTER, and what the miniBOOSTER allowed us to do was to install the miniBOOSTER right on a fairly small half-horse little electric power unit. And what it did then is they actually had it with a high-low pump installed on the little power unit, so it would extend and retract the cylinder at relatively high speed. He'd put a pilot-operated check around the miniBOOSTER and to extend and retract a double-acting cylinder fairly quickly. And then once it reached the full extent, it would go into a standby mode, and with a 4-to-1 ratio on the HC2 miniBOOSTER, he could achieve up to 3,000 psi with a 750 psi bypass, which is roughly about a half a horse. I mean, it wasn't even a half a horse because he wasn't running 1 GPM towards it. So he was able to put just a little air heat exchanger behind the electric motor. So it was a much smaller package, less expensive, didn't generate the heat that the larger power unit produced, and it was fairly quick because it had a high-low pump in it, and it meant that he could extend and retract the cylinder much quicker. So worked out very well for him, and was a much less expensive package than the 2 other systems that they were considering for those applications, for that application. So but that was a couple of good places to use miniBOOSTER. There are a lot of other type applications where miniBOOSTER work very well. Probably one of their bigger applications is in machine tools, where machine tools commonly come with 1,000 psi hydraulics, maybe 1,500 psi, and when they get a machine, that might work fine for the existing project or that they're working on, but what often happens is they get a new job and they might have different fixtures, different work holding. They might want to put a bigger piece in there, so they need more pressure to hold that. So it's a great place to consider a miniBOOSTER. You can up that 1,000, 1,500 psi up to 3,000, 5,000, 10,000 psi if you want. But commonly they're boosted up to 3,000 to 5,000 psi. So great application, probably one of the most common applications for miniBOOSTERs in the machine tool world. They get used quite often in subsea applications, ROVs, remote operated vehicles where they've got the tools operating undersea. They might be running a cutter or a crimper. A lot of those tools, subsea units, ROVs, operate at up to 3,000 psi, so they can boost that up to 5,000 psi, 10,000 psi, depending on what the tool is. There's some other good applications where miniBOOSTERs had success over the years with rail stretchers, fire and rescue with operating the emergency tools. They could have 3,000 psi on a fire truck, and you can boost that up to 10,000 psi is what a lot of those tools require. So that's a great application. Again, you can run low pressure all the way up. These things are, again, relatively small, so they could go right at the tool. So a point of use boosting of up to 10,000 psi. So you can do that with low pressure hoses. In construction and demolition applications, excavators go up to 3,000 in Europe, 5,000 over here. You can boost those up to 5,000 or 10,000 psi. for shears or crushers. So again, another good application. Aerial lifts up in the bucket trucks. A lot of those systems run 3,000 psi. You could have a small mini booster up in that bucket, boost those pressures up to 10,000 psi to run a cutter or a crimper on some of those big power lines. When they're crimping those large power lines, it's a 10,000 psi tool. So again, a great application. Torque wrenches quite often go up to 10,000 psi to operate a torque wrench. So again, you could operate that 10,000 psi torque wrench with a little 3,000 psi power unit and save quite a bit of money just being able to have a low pressure power unit versus a several $1,000 high pressure power unit. And then another one more application that comes to mind is service trucks and the jacks. So a lot of the service trucks have again gear pumps on there. They're operating at 2,500, 3,000 psi. You could tap into that hydraulic system and operate a high pressure jack cylinder, again something that operates up to 10,000 psi with an existing hydraulic system on your service truck. So those are some of the applications that I've worked on and seen over the years, and they work fairly well for those in those areas. I kind of like to, I don't know, I like to think of the mini booster like the genie in the bottle from the Aladdin movie, phenomenal cosmic power in an itty bitty living space. Well, I like to think of it as phenomenal hydraulic power in an itty bitty package. So that's a good way to think of the mini booster. So I guess I would say there are some things to consider when applying a mini booster, and I imagine the three things that I always think of the most when I'm applying a mini booster is you want to limit the amount of flow that's going into them. A lot of them are rated to like the HC2, the most common size, is rated to 14 liters per minute, roughly 3.5 GPM going into it. The pressure, the max pressure going into the mini boosters is 3,000 psi. You can obviously increase the pressures with ratios all the way from 2:1 to 20:1. So very high pressures on the output. So commonly up to 10,000 psi is where a lot of those applications are. And then the other thing is you want to keep, since these are a metal to metal contact on the inside of the mini booster, there's no dynamic O-rings or anything like that to seal the surfaces. So you want to keep your hydraulic fluids clean. And with those three things, when you're designing them into a system, if you keep those three things in mind, then that's a good way to apply, and you get a long life out of the mini boosters. And we've had mini boosters out in the field in certain applications up to 10 years. So it has a lot to do with the duty cycle and the application, but we've got boosters running in the field, like I said, in applications 10 years old. So great product when they're applied correctly, and we'd love to talk to you about any applications that you might have and see if mini booster would work for you.
Thanks, Dan. Those were all really excellent use cases for mini booster hydraulic intensifiers. Let's switch over to David to talk about some of the specific mini booster models.
My name is David Holcomb, and I'm the Regional Sales Manager of the Eastern United States and Canada for both mini booster and Zynga. All right, so mini booster has introduced 3 new intensifiers that offer additional functionality by incorporating a control valve in the HC22, a sequence valve in the HC25, and a PRV and sequence valve in the HC225. All 3 are based on the HC2 series of intensifiers and come ready to plug and play. With over 25 years supplying point of use solution for the need for more force, mini booster expanded offering ensures efficient operation of the intensifier, shortens system cycle time, and also extends service life. It's a one-stop shop package for you. The HC2 series intensifiers are designed for smaller volume applications, such as work holding applications. On applications with larger flow requirements, miniBOOSTER has developed several larger intensifier-based systems. These larger systems will incorporate additional functionality to ensure that the intensifier is operating within its specifications, while at the same time meeting the flow requirements in the process. Some of the intensifier systems have free flow capabilities in excess of 100 gallons per minute. One of the issues that we have seen is intensifiers that are damaged due to overflowing. And so intensifiers, like car engines, don't last long when operated in the quote unquote red zone. This is the beauty of the miniBOOSTER system solution. All of the components to ensure safe and efficient operation are included in a company manifolded package with a single source responsibility. One of our customers, for example, in the oil and gas industry that designs and manufactures top drives, roughnecks, wrenches, and other components for drilling rigs, already used our intensifiers, but they wanted to extend functionality, including higher flows and limiting operation of the intensifier. So as a first step, we supplied them with the HC2 intensifier combined with sequence and control valves, adapters. Based on the customer's testing, we're able to design an HC3 3D based that included the additional functions and flow capacity that permitted the customer to adopt the design in multiple products that then required high flow and high pressure, or that did require high flow and high pressure. Engaging us early in the design process, like the success story we just mentioned, can yield additional efficiencies, and the gains are unimaginable. We'd love to hear from you as a group on your challenges and applications, those that require higher pressures and higher flows, and see what we can do to help you out on those.